everybody, and very happy to be here. And this is our monthly call, and we are recording this session, so we also want to publish it later. But this is like just to contain the announcement. So generally, what's happening is that it's sharing only my camera and the sharing screen. So if anyone don't like it, please let me know. I can also remove you or blur from the video before we publish. Okay. So
I'm very shy, as you know.
I know, Frank. It's also very good to always welcome like Francesca and Frank, our great friends, always join here and gave us very good feedback apart from all the contributions in the community. And well, my name is 𝗥𝗲𝗹𝗲𝘃. I'm a developer advocate. I also try to help a lot in the community now, like working as an interim community manager. I am from Brazil. I live in the south of Brazil, and yeah, I also I expect like probably Chris will join, but today is his first day of vacation, so he's traveling to Japan, and probably he was quite busy. So let's see if he will join. Yeah, and well, we have this last month we have a minor release, and we don't have like any let's say a special feature. It has a lot of bug fixes, and yeah, I will not go one by one, just having the list here, and also saying thanks for Justino Zavala and 𝗥𝗲𝗹𝗲𝗃 and 𝗥𝗲𝗹𝗃 Yeah, so we have a few community members that are contributing to the TimescaleDB extension. We also have several other projects, but that was a very good one. And this is the release notes from the TimescaleDB extension. We also have a new release of the toolkit, which we have new stabilized functions, which is very good. So as you know, when you have like experimental functions, you cannot use them in production, even if they are cool. So we cannot guarantee they will not be removed in a future version. So now we have more stabilized functions and a few bug fixes as well. And if you are familiar, we also have upvoting system. We track who is tracking what. So if you have some new ideas for Timescale or things that you think would be useful, just go to our upvoted requests. Every month we share it in the general channel as well. So yeah. And the last one that has just one upvote is split hypertable by chunk size limit. So that's a very good idea. Some people are trying to think about this more like dynamic and static size instead of like thinking about time intervals, which would make Timescale even more like approachable to non-hypertable or non-time series style, right? Yeah. Well, now let's go to community questions. Francesco, as you submit in advance, the stage is yours. You want to share? Do you want to share your screen, or do you want me to share? I have it here. I have the file that you shared today early, and
yeah, you can share that for the time being. And I looked for the page where I got my details from Timescale, the Timescale docs, regarding the random generator function.
yes.
Yeah, this is the one I have a query with, but it was really good actually. It's very easy to generate random time series, simulated. Here it is. I'll put the link in the chat.
Okay, awesome. Thank you.
Yeah. Oh, is this it? No, that's not it. Hold on. Yes, but it seemed unnecessarily complicated. For example, I had temperatures data, and the temperatures data, generally, you can't have a maximum of greater than 100, and you can have as many floating point numbers as you want, as many significant figures as you want. But the problem was I only wanted, say, 1 or 2, because that will keep it nice and simple. But with my random function, there was this double precision data type. And the double precision data type comes with 15 precision digits. So if you take the 2 that you've got to have for the temperature, not above 100, remember, the rest of those digits, the 13 others, have to be decimal places. And what happens is these values now, because they're temperature values, become very, very long for each actual observation. Right. So when you go to, say, transfer to disk, or to save to disk, or export into a CSV file, you find that the actual file saved, the CSV file saved, is really, really, really big, even though it might be a small time series. And I was wondering if there's any way of getting around that, because it comes out of the box like that. I had to do some rounding with a round function, and I think a truncate, but it took a bit of time to get the hang of it, because the actual random function does not easily adjust to the actual random function, which is also shipped with Timescale, or Postgres. So it took a bit of time to work this out, but I did manage to get it to 2 significant figures before actually exporting the actual data into a CSV file. This is the random data I had generated. I had to insert into a table which I had created. See if I could find it. And after that, I had to export it before I could import it again. Now, the reason I had to export it was to get it into my file system, for one, in a CSV format. And so what happened, it grew something enormous in that process. Right. Yeah. And with the 13-digit decimal places, I had to say no. My test file was only a 1 year or less than 1 year, but for something like 10 years or 20 years, it wouldn't have been possible. I'll try and get this. Where is it? Here we are. How you simulate data? Here we are. I had it just a second ago.
Yeah. If you get random, you see that it's really a huge number, right? Yeah. So. And
there we are. You can share my so no, I'll put it in the description.
Sure.
No, that's gone. Oh gosh. Here we are. I'll put the link in the description.
Okay.
Okay.
Where exactly are you sharing? Just to.
Pardon?
What chat are you sharing this message?
What
no, where is the link that you are sharing? Because I couldn't.
I haven't put it in yet. I haven't put it in. Sorry, in the discussion. Here we are.
Okay.
I haven't put it in yet. There we are.
Okay.
Okay, and you can just put it up on the.
Yes. Yeah. Oh yeah, I have it here. Okay.
Right.
Yeah, and I got your point here. So we have this problem, right? So for example, if we go here and just say select random, we will have this like very huge number, and if we multiply by 100, we will not get that much difference, right? So we will just like move, but we would need to do some round too. For example, here, if you want to limit this thing. Round does not exist. Double. Oh, it's not like this. Sorry. It's round.
I was wondering if there was any way of making a version simpler for people to use, because it's such a large. You can see that the temperatures values there are very long, and that takes a lot of storage space.
Oh yeah, we have
like I only wanted 2 decimal places for mine.
Yeah, so you need to multiply it again, right? So for example, if you if you multiply it by like so then you can just
but it's not intuitive. It's you know,
yes, I totally agree.
you have to work it
And
out to get the right values, and it took a
yeah,
while for me. I had to apply a round function to it, and I wasn't that familiar with rounds and truncates, but it worked in the end. It was okay. I got the two decimal.
yeah, like
And I was thinking, could you get something similar as a not alternative, but an addition to it in the docs?
yes, totally.
Or an example.
I was working now on this generate like temperature series,
Yeah.
which could vary here, like from like temperature fluctuation into some average, but it's still a very full algorithm, but it can do something like some ups and downs, and so you basically you have this temperature series. So for example, if I go here, yeah, so for example, if I generate temperature series, it will let me get like 24, 23. So I have like 5 degrees like every day as a difference, right? So, and to be honest, I was also very feeling very bad about like using this random function for time series data, because like the compression level will not be fair as well, because like the compression over deltas will be different, right? So you will end up like using a different compression system, and probably will not compress that well as if you use a real data. So I am trying to think about like we get a series, real-time series data, and create some advanced random function, which I could say, for example, a random temperature, and then it generates a series of temperature, or a random.
Okay, yeah, and then you wouldn't have the floating point issues. Yeah, well, that's a good idea, but it's a very good function. I like it, but it's difficult when it comes out of the box like this to get more files. If you have 100 years or something, 10, 20 years, that's a lot of digits, and it doesn't. I haven't got a lot of RAM, unfortunately. It's probably my fault.
Andrew, you want to say something?
Yeah, so I had to cast it to a numeric. That's what it was. I had to trust, before even rounding it, I had to cast it to a numeric, because the actual round function apparently doesn't take the double precision data type, which is what it was. Yeah, that's the answer. Someone's got the answer. Frank, yeah, thank you, Frank. That's right. Yeah, cast it to a numeric, but you can
make your own function if you don't like to type that all the time. You could make
yeah, that's what I did. That's what I did, you know.
I mean, the problem with generating simulated time series data for IoT sensors is you need state, right? Like you can't, it's not random.
Yes.
But the first time I had to do this was almost, I don't know, 12 or 15 years ago, and there's a really embarrassing bit of Python code somewhere on GitHub that I called brown data, because it's like brownie in motion. Like that's what you really want, is brownie in motion, where you have a little bit of random, but you take the you take the XY and turn it into a single direction, and that gives you like steps and jumps, but not big jumps. And then Brian, who's in the call as well, is with me, and we have a question whenever y'all are ready for another one.
Yeah, we can go to the next one.
Integrals.
To go for it.
Yeah, using integrals to estimate the most.
So I'll lower my hand then. We have been working with continuous aggregates, and have run into some issues with the new cascading continuous aggregates, or hierarchical continuous aggregates. And I can share my screen if that's easiest, whatever works.
Go for it.
Yeah. So I think we were looking, basically things work great 1, maybe even 2 levels down, but when we get to the 3rd or 4th continuous aggregate, it basically never returns when we refresh. And so I was hoping you all could look at this and maybe there's something blatant that we're just getting wrong, or
Oh
you
yeah,
can
right
tell us
there
it's
on
not.
line 73. I'm kidding. There's no
Oh.
way we can glance at this and immediately give you a.
Hey.
Frank, that was a good one. That was a
All
really
right, you got me. You got me. I was really hoping that was the case, though.
That was
he got
awesome.
me- he
Frank
got me
is
too.
now my favorite person on this call.
Yeah, he got me too. I was looking at 73 as well. So one thing, because I think it's only going to be fixed in 2.10.2 and 2.11. You have to change where you have to set the chunk time interval after creating the continuous aggregate. Because the original idea was like, when you create a continuous aggregate, you get about 10 times the size of the original chunk. So if you had 1 day, the continuous aggregate made it 10 days. The problem is that applied to all levels. So the next continuous aggregate already had 100 days. The next one had 1,000 days. The next one had 10,000.
Well, I was looking at the explains and like, you know, it was turning these things into like infinite, you know, negative infinite ranges and stuff like that. And that aligns with that.
Yes.
Okay.
So you certainly want to set a chunk time interval.
So I can do that on here, or
no, you would create it say with no data,
right?
In the end, right? So no with no data, so that you get an empty continuous aggregate.
Okay.
Then you set the chunk time interval, and then you just call refresh continuous aggregate manually.
Okay.
Hey,
And
Andrew, I'm curious just why we have the ID, UUID as a primary key. Like, is it like some like real need from the business, or like because it seems like a serial value, right? Like a unique value. The line 59, and you can see it in the line 63 as like a combination primary key. It can also slow down a lot of things. I don't know if this is like a, oh no, this is also a group that you use, right?
yeah, so
It's like
I mean,
a foreign key or something.
right.
Okay.
It's the unique time series identifier.
Okay.
I would always be cautious not to use a column alias as the word time. Because if you've got a real column as time somewhere.
I have changed that in the most recent version, because we decided, well, maybe we're like somewhere deep in this is the part that we know is broken. I have another environment where we've been testing.
Right.
Because I think another learning from all this, and maybe you can tell us, like, if we get that chunk time right, does it make sense to have this granular of continuous aggregates, or are we wasting energy for something that we're always going to be querying the actual hypertable anyway?
So let me see. You have 1 minute, 5 minute, 15, 1 hour. Well, so here's my thinking. I guess it depends on how many different rows you will still querying, right? If you have 5 rows for 5 minutes, you probably can get away with not having that. If you have 15 rows for 15 minutes, well, that's probably good enough as well, right?
We think we're going to have, for each instance of Timescale, we think, and this like schema, we think we're going to have a mix of second data, of maybe 1 minute data, maybe 30-second data, across maybe probably like 5,000 to 20,000 UUIDs per instance. And that's, maybe there'll be some that are more, there'll be some that are less, but somewhere in that range.
Right, but when you aggregate from 1 minute to 5 minutes, is that just like 5 rows now? Because that's what it is, right?
It's going to be 5 rows times 20,000, or 5 rows times.
Right. So in this case, I'd probably test it out. The thing is, for chunks, you always want to make sure, or for time buckets, you want to make sure that you find the sweet spot, right? Chunks should be large enough, especially when you look at compression later on, because we always compress like batches of 1,000 elements. So the second you're lower than that, That will certainly be an issue.
Okay.
And hit compression rate and ratio and stuff. I would test it out. Put in some data and see if you really need that, for example, the 5-minute and the 15-minute. If you're not, that's okay. I mean, you can always drop them in later on, right? As long as you don't throw away the 1-minute data, you can, and you figure out, okay, I need 15 minutes now. I see Frank has hand up and he's disagreeing with me. I see that.
No, I agree
angry
with you. I'm
face.
just wondering if you've got, you've created the 1-minute events, then you could easily create the 5-minute ones on the fly. You don't need.
That's what I think too. I think that's what, like, we wanted to test, like, this was initially like, let's test all the things we know we're going to be querying at as continuous aggregates. Like, we know that for some views, we're going to want 1-minute data. For some views, we're going to want 15-minute data. For some views, we want 5-minute data. But then we ran into this issue where we're like, we could never get 5-minute, we could never get 15-minute to refresh, like, ever. Like, we got 1 minute, that was really fast, it worked great, even on, you know, billions of events. We got 5-minute, and that was a little slower. We're like, wait, why is that slow? It should be dealing with, you know, 60th of the data. And then we got 15-minute, and it never returned. So we've, you know, that we didn't get to the performance testing that you're talking about because we got stuck on that.
Right,
so.
right. But I'm completely with Frank. That's what I meant. I would leave out the 5 and 15 minutes and see if real time reaggregating is certainly fast enough, and I guess it will be. And if not, you can always drop them in between and just quickly change the query.
And it's a static number of cycles, right? From minutes to day, it's still like very easy to handle, like a few thousand rows. And like what we see, for example, some people they have these continuous aggregates with real time, and then, like, for example, they process the day, and then like the volume of ticks during the day is very heavy. So sometimes they mix like a day aggregate instead of using real time, the union with like hour aggregate, and then they can get the real time. And yeah, that would be another idea.
I think in all these cases, we will likely be querying maybe not all the cases, but a lot of cases we will be querying real-time data alongside whatever the like aggregate we care about. But that's fine. We're okay with paying that performance.
Yeah.
Cool. Okay, that's super helpful.
Thank you very much. Yeah, you are welcome.
And do you have a recommended chunk time? Is it still do 10x of your original data sample, or is it 10x of the aggregated, the continuous aggregate time sample? Or
and is it the chunk size or is the chunk time interval?
The chunk time interval. So if you had 1 day, it made it 10 days, 100 days, 1,000 days, which is certainly stupid, right?
Can you walk us through the documentation on that?
Sorry?
What is the modification being done to the hypertable regarding chunk time intervals? You had that as one of the items that's
there's always the materialized view is another hypertable, and he's saying you need to set the chunk time on the type view in the hypertable for the material.
Right. You use set chunk time interval with the name of the continuous aggregator. We'll look up the underlying hypertable for that. So it will not change the raw data hypertable or the original source data hypertable, but it just took whatever chunk time interval that had, multiplied it by 10, and took that as the new one, which was.
Chris, if I understand you, so like, let's say you have a chunk time interval of 1 day on your raw events.
Right.
When you go to make an aggregate from that, it's going to be many times fewer values ultimately.
Right.
So if you make the chunk time interval larger, then you will be able to have more values inside that chunk, and you won't wind up with lots of little teeny chunks. Right.
That was the idea why you multiply the chunk time interval by 10, and that made sense for the first level, but it took the same multiplier for additional levels, which exponentially grew quite quickly.
Okay, so you guys do a default when you're creating a materialized view,
Right.
chunk time interval in your code, and we should overwrite that with the sensible number when we are cascading.
Yeah, to be honest, I would recommend doing that anyways, because you have most knowledge about your data, and you would understand how much less data you generate per continuous aggregate. So I would recommend doing that anyways. That's
So can you just
I'm blessing that idea.
Can you walk through the documentation where this stuff is at? So just so I make sure I'm on the right spot and see everything.
Yeah, let me find it real quick.
Because I kind of looked for this, but I apparently missed it.
Well, it as I said, it was a bug, and we figured it out because somebody brought this up, and it took us quite a few hours to figure that, and eventually it was like, that is very wrong. I think that's the standard where it set chunk time interval. There you go. It's the same function as for the hyper table.
Okay.
No, not that window, that one. There you go. Oh, somebody was faster.
Yeah. So do you know how to get the chunk time interval for a hyper table
right now? That the one that's set. Yes. Let me find the query.
Well, and it seems like it might be easier to do in 2.0 than it was in 1.x.
Yes.
Is there a way to do it in 1.x?
Yes, but you have to dig around.
I'm pretty sure there was, but I don't know how right now. And I don't have
7 days,
1.7 running anymore.
7 days was the default on the normal hypertable.
Yeah, it's still 7 days, and I think that means the multiplier was the same thing, but I'm not sure if how you would look up the time interval for that.
What was that query again?
Detailed size is the function.
Just trying to come up with the query. I know I have it somewhere.
Chris, I use the one chunks underbar detailed underbar size.
Chunks under. Oh, right. Okay, fair enough. Yep. I didn't think about that one. That makes sense.
But I think that's the one that's definitely 2.0 only.
What you mean, the timescale version?
Yeah.
So select a star from pg_catalog.pg_extension, where whatever name, I think extension name, where X name is blah. I think that way you can just make it dx. Can you? I think so. Just make it \dx. I think that will give you the version 2.10.1. There you go.
What was that again? Hit up. Oh, I see. PG_what? I'm trying to. Okay, there we go. PG catalog. Okay.
Right. That has all the information. But dx is the short version for just show me all the plugins with version and stuff.
Okay.
And as I said, I think this bug with the continuous aggregate is fixed in 2.10.2 by only applying the multiplier to the first level, which I think is not an actual fix. It's just trying to work around the horrible issue. So we're still trying to come up with a better solution for that. My personal feeling is we should force people, when you configure a continuous aggregate, we should force people to say what the chunk size should be, or the chunk time interval.
So you are not aware of a way of getting that from 1.7?
I'm pretty sure that was a way. And you still have the old documentation, but
you can try to find it on the _timescale catalog.
Okay.
Yeah, we have like a schema with all the metadata. Probably it's on dimensions. The dimensions is the actual let's say way that we track the chunk time interval. Probably this is the same here, like \d.
Yeah, it is. Okay, cool.
Yeah,
it still tells you the version. But it doesn't, I'm not sure if the...
Yeah, it's got the interval length.
Oh, does it? Okay.
Yep, it's called interval length.
But
okay.
1.7 doesn't have hierarchical continuous aggregate.
No. Two different.
Oh, okay. Okay, fair enough. Gotcha.
Okay, anyone has any other questions, anything that want to share?
Brian, did you have any other burning thoughts while got the team here, the super team?
No, I mean, if you're satisfied, we're satisfied. I mean, you're playing guru for us. So we're just sitting here trying to figure out what the hell you guys are talking about.
Chris, how did you get such pretty output from your PSQL commands with the little lines around it?
Oh, this is a configuration. You need to configure it on .psql_rc. Yeah. And then like I'm using border 2 and line style Unicode. So yeah.
Pretty.
You understand you will not be able to run the unit tests, right? Because now all the output will be wrong,
Yes.
I guess.
Yeah. I need to several times I need to disable that thing. So.
Fair enough.
Yeah. Okay, so
are you finishing? Oh well, before we finish, I have some more questions for you from this little tidbit of benchmarking. Actually, these benchmarks continue from what I did before, but the data sets are much bigger. Now, I just put it in a nutshell. I have 16 GB of RAM on a 10-node cluster, each having 16 GB. It's a development cluster just for testing out TimescaleDB and other time series databases. Now, one of my files that I'm going to do, and in fact, I'm doing them now, they're cooking now, is I have to input a 21 GB file on 16 GB of RAM. Now I'm using the go parallel copy command, which is the timescale parallel copy, to input the data. Now I don't know what's going to happen. I've got the one table prepared for it. Now, if we have 21 GB file, a CSV file, and only 16 GB of RAM, what will happen? Can anyone give me any ideas what will happen? Will I corrupt the data? Will it kind of give up halfway through and then I have to do a cleanup of what I've already written? Will it be okay for me to just go ahead and use the parallel copy on the whole 21 GB data set, even though I only have 16 GB RAM? If I do, in fact, split it into two files, one of 14 and one of 7, or even 8, and no, so was it 14 and 7? Yeah, and that is okay. Now, when I create the timescale hypertable,
right,
will it continue to add the second data set to the first data set, or will it say no, you cannot add any more data to this data set?
I think you never put all the data in memory, so you'll be flowing data, right? So think about like you have like a buffer size and then like you read like 1 megabyte or 10 megabytes, and then you flush it, and then you keep flushing. So you never put everything in memory.
Okay. So
Yeah, that's the thing. I hope like your custom program that is doing the benchmark is not like reading the entire file and then pushing it into another direction. So think about like your process should like read one line, parse it, transform your data, flush the insert, and continue, or doing a batch like 10,000, 5,000 or something.
That's right. Okay, so you might not have any problems with that. Even
No, it will just work.
Oh, that's nice.
If you go and just say, for example, you have like a 1 terabyte file on PSQL, and you go and say PSQL -f and just send the file, it will not read the file and put it in memory. It will just keep sending, as you can do pipe for PSQL. So you say, for example, let me share my screen really easy here just to show this like a small thing. For example, if I say here echo hello, oops, sorry. Echo here, select 1, and then I can say PSQL playground, for example. So I execute this select 1, right? Like if I have like a file or like even like a process here, for example, let's say here I have like a unzip. For example, unzip my file.zip pipe PSQL. You could also get it like and unzip will not like unzip the entire file, but just like
even with the zip function. All right.
Yeah, you can use Linux to solve this issue.
Oh, that's good. That's
standard out from the first process gets fed to the standard in of the second process.
Yeah.
And they both processes run at the same time, and it consumes the input as fast as it can, and the other one will.
Right. That's why it's called pipe operator, because you're piping the data from standard out to standard in.
This is why Linux is superior.
Totally. Unix in general. Yeah, I agree.
I
mean, Windows has named pipes. Yay.
Can the generate series support a crap, what are they called? Like having a lag?
Oh yeah. Lag.
What would be the
you want to time shift it, or what do you
mean? That's a lag is just time shift. Might be lag 1 period or 2 periods, up to 3 or 4 periods. If you have quarterly data, you might get lags of 4 periods.
So that you could do a sum of a random step instead of just the random output for your simulation.
Oh.
To get more continuous data.
Let's say 1 minute, and then I have like an interval of 10 seconds. Oops. Oh, my interval is wrong. I need to say in the inverse. So let me just, yeah. I don't know if I got your question exactly. Like, how would you think about lagging? Would be like including like some 50 seconds in the middle here?
Why?
I'm saying that can you use that as either a can you use that as a CTE and then call it with a window function to have access to a lag, so that you could sum, instead of having random as your value, you could have sum of lag plus random, and then you would get your steps, your like small continuous steps you were looking for. It might be a simple way to do your simulation, your like single query simulation.
Can you explain to me, actually, while you're here, can you explain to me why the interval on the start date is different from the interval at the end date? Now, I noticed that in the docs, and I couldn't work out why it was. That's exactly what it is like in the documents, which I use the random generated function from, but I hard-coded the start date and end date you've got now. But why is the interval not the same for the start date and the end date. You've got 1 minute interval for the start date and interval of 10 seconds for the end date. Why is that?
His span of time is 1 minute, but the individual values within that span are 10 seconds apart.
Can you repeat that, please?
So what it means is you're generating data from now minus 1 minute to now in 10-second intervals. So you're generating 10 values, or no, it is 6, 7 values.
Again and change it to 5 seconds, and it'll be clear.
Right.
Please.
All right. Yeah, it's split up. The minute is split up into 10-second intervals.
Right.
Right. Okay.
And because it's inclusive, you also you get 7 values because the last one is actually in the 10-second interval again. Something that always it drives me nuts with generate series, that the closing value is inclusive.
So you can take a microsecond off the end time.
That is exactly what I'm doing in my unit tests.
Also,
Like when I want 10 minutes, and on a minute granularity, I do like 9 minutes 95. Bam.
And I also would round down the start time because I don't want.
You're gonna have to cast your random generator function because the data type isn't allowed. You have to cast it to a numeric.
Yeah. Yeah, that's the thing. Yeah, but I was trying to tie it to just I need to say something like text interval. Yes, yeah, then I need to work. And then
you can also make it minus interval 1 milli. That works perfectly.
Your end
fine.
time of that make minus interval 1 milli or 1 micro.
Or yeah, whatever. -1 unfortunately doesn't work because it doesn't have like a value now.
I wasn't saying generating new intervals. I was saying just filling your values with numbers that were not completely random. They were random steps away from each other using the lag.
Yeah.
Oh, random steps away from each other.
Yeah.
Got it. Got what you mean. Yeah, I think you can do time.
Where is that in the 2.x documentation? Because it used to be like advanced analytics or something. They had the examples for using windowing functions. But
isn't generate series a PSQL function, a Postgres function? That's not.
This is Postgres, not.
Yeah, but I'm just saying I'm just not sharp on window functions in general in Postgres, so I'm just trying to find the example that y'all used to have in the documentation.
Mm-hmm.
It may be that it is gone from the new one, to be honest. But I also see that somehow the old documentation. Oh no, there you go. Latest. Do you know where it was in the 1.7?
Advanced analytics, I think it was called, or
Timescale analytics.
Something like that.
Yeah.
So certainly with the generate series, you don't have to generate timestamps. You could generate integers, and then you can use that integer as a parameter of the lag to pull data from somewhere else, right? So
I don't even say I'm saying just in this from that original point that like excuse me, the IoT simulated IoT thing is like not realistic data. I was just trying to like come up with a one-liner that like solved that.
What I commonly do is when I'm simulating like voltages on meters, I use the random function to make a deviation away from the. So it's 220 plus or minus a random number multiplied by this, blah, blah, blah.
Right.
But I want the last, I want it to have the full range from 0 to 100, but each step is a random, say one random percent, random 1/10 of a degree, random 1 degree.
Yeah, you could probably do that fairly easy with recursive query, where you just every iteration you
select the previous.
You select the previous plus some random number, and stop at some point.
The thing.
But I hate the syntax for recursive with clauses. It always mangles my mind just trying to come up with something. But that would give you at least a one-liner if you want to drop all of that into one line.
I'm looking for a set of queries that I've found in the past for generating a variety of random data that has certain characteristics. And if I can find that, I will send it along to you.
Oh yeah, cool.
That would be amazing. Yeah, and maybe we could also consider it as part of like some YouTube's libraries that we can keep it around, because this is so useful, and all the time we use this random function that's so wild. It does not work for what we want, right?
It has a reason why I have all the examples pre-coded, because just getting the order right for all the generate series, and as I said, the inclusive, exclusive values and stuff like that. Yeah.
I just do this in a programming language outside of SQL, but you know, whatever.
Yeah.
I saw that you also use nats, which is really cool.
Oh, was there something showing up in there about nats?
Yeah,
Am
it was
I leaking
something
secrets?
nats py.
Oh. I was
Very
playing with
cool.
it. Yeah, I mean, it's a really interesting technology. I've been using Timescale for, I don't know, a long time. And really like it. And then I'm working with the company that Brian represents, who was on earlier, helping them adopt it for some edge use cases. But I also was encouraging them to try out nats and showing them some of the benefits of that. So
Yeah, there you go.
So, cool tech. I mean, and like, you know, depending on how you architect your system, like maybe nats is the right place to do some of the more real-time aggregations for what they're doing, and then only parse the continuous aggregate data like from Timescale. Let Timescale, like, don't even touch the real-time flowing data into Timescale. But
Right.
We'll see where they land.
That could be, yeah, that could be something that may be interesting to you. I'm currently working on a CDC implementation for Timescale, and that can pump data into Kafka, nats, Kinesis, or whatever. So just in case, it will take a few more days, and I'll officially be on vacation for the next 2 weeks, so I won't work on that. But it may be interesting, especially when you say that you may want to pump it somewhere else for some more real-time stuff.
Well, in this case, they're going to have nats on the front end on the collection side,
Right,
and then be feeding it in. Is there a canonical, like, I know that, like, from a company perspective, it's use Timescale Cloud and then you get your backups and HA and all that, but is there a canonical streaming replication?
Well, yes, it's called Postgres streaming replication, physical replication.
Yeah,
no,
so
it is.
If you look at the Postgres chapter on replication, they say you can do any one of these 5 options, right? And none of them is perfect.
I was pretty happy with crap. What was it called? The Disney movie one.
Pixar.
Yeah, it was a Pixar, exactly. It was a Pixar film. What was it? The robot.
WALL-E?
WALL-E, yeah. I was pretty happy with WALL-E. And when they went to WALL-G, I've had trouble getting WALL-G to do what I need it to do. It's obviously better, faster, stronger, but
right. So the Helm charts just use Patroni as cluster manager and just use hot standby. So standard streaming replication for the copy part.
The beauty of WALL-E and WALL-G was that you didn't have to have object storage
for backups,
sitting there for a secondary cluster. You could just have all of your WAL files in object store, and then
you can do the same thing. So as Frank just said, PG backrest, that is what we use in the Helm chart. You can store it to S3 and whatever the Azure blob storage, and that works pretty well. We used it with my startup. It worked nicely. It saved our asses quite a few times as well.
Okay, so thank you very much, guys. I think just the final announcements here. I think this week, tomorrow, we have Mathis speaking at PG Day Chicago. And in May, we are going to be on Bitcoin Miami. So if anyone is around and want to say hello, we have a booth in Bitcoin Miami. And tomorrow, we have Mathis speaking on Chicago PG Day. Right, and if you are running a meetup or want to have our team talking, or some place which you could recommend us, we are always looking for places and more TimescaleDB enthusiasts to be joining. And thanks for joining. So we'll see in the next third Wednesday of the next month. So see you.
Obrigado.
Thank you.
See ya.
See you. Bye.